Hello and welcome everyone. So we are going to do a solution video for economics of entrepreneurship. And so I'll show you the exam and just to kind of remind us of it, or for the future for studying or whatever. Just let me go over this kind of, I don't know, slow and quick because I'm bored, but slow enough that you have time to stop the video and look at the questions and then work through them if you didn't already take the exam or don't remember them or whatever. And then we'll talk about them. All right, so let me show each of these. Make this a little bit smaller. I don't know, or just shift it down. Here's the top part. Here's this one. Good. Okay, so there's only a couple more. And then this one and that one. Okay, I almost fell asleep doing that, so hopefully that was okay. And you think I'm kidding. All right, so the goal of limit pricing for strategic entry deterrence is which of the following? To legally implement predatory pricing? No, you can't legally implement predatory pricing by definition. To maintain oligopoly power as long as possible by discouraging entry. I didn't read that right, but it doesn't matter because that's not correct, right? Because you don't have oligopoly power. It's not going to work, actually, limit pricing. You'd have to be a monopolist, or you'd be colluding in an oligopoly. To try to make your product as similar to your rivals as possible so you can limit price competition? No, that's something completely different. To make entry unattractive by suggesting the market demand conditions are unfavorable. Yeah, that's how we discuss limit pricing. As discussed in class, if a new industry is one with the potential for large endogenous fixed costs, then this was the one where we said, we compared two sequential entry games to model these different industries. And we said in the first one, where there's no endogenous fixed costs, both firms enter and split the market as an oligopoly. However, if there was an endogenous fixed cost and you paid that cost up front as you were entering, and any rival entering the industry would therefore have to match that fixed cost, there wasn't room enough for both. And so you'd end up being a monopoly. So the most important thing was to take advantage of this first mover advantage, be the first one into the market, because the prospective rivals will find it unattractive to enter because they don't want to pay that fixed cost because they won't be able to recoup it once you've incurred that cost that they would have to match. Let's see. So once you've entered the market, you ultimately need to accommodate. Nope, that's exactly not the structure we were thinking of. There's likely to be a very strong second mover advantage, the ability to mimic the quality investment. Nope. So we were thinking about a really large endogenous fixed cost, right? So we were talking about the example in class where there was actually a first mover advantage, not a second mover advantage. And we didn't talk anything about mimicry or something like that. Goal of advertising: make your demand curve more inelastic, make your rivals more elastic, make your consumers find fewer substitutes for you, more substitutes for your rival, namely you. Increase the maximum willingness to pay. That making your demand curve more vertical does that. Increasing the size of your market, making your demand curve more horizontal does that, but actually you want to shift it out rightward and get both of those. To compete with your rivals without doing so using prices, advertising is non-price competition, so all the above. Which of the following are important to performing value-added analysis? Value-added was looking to see, is there a big gulf between the demand curve and supply curve? So you want to verify that consumers are willing to pay a lot for this and it relatively doesn't cost very much to deliver that value. Identify number of rivals and nature of any competition? Nope, that's for Porter's five forces. Determining whether or not a monopoly is legal in the market in question? Nope, not relevant at this point. You want to do your value-added analysis first. And usually it's not illegal to be a monopoly, it's just illegal to abuse monopoly power. So we'll discuss that actually later in the course. Investigating whether it's possible to produce the good or service at low cost relative to consumers' willingness to pay. I gave that example, and the example I like to talk about is flying cars. We don't have flying cars. It's not because people don't want them, but it's because you can't deliver them to the market at a price low relative to what people would pay. All right, so suppose you've conducted a survey to estimate your demand curve from 5,000 randomly selected respondents. That's a large sample. Your survey is presented two possible prices, each to exactly half, so $10 and $15. Using those 2 points, you determined that based on your estimated demand curve, the profit maximizing price is $20. You should think of this like the pet sitting example experiment that I talked about, right? Surveys. Be suspicious of the result because you've not explicitly controlled for the other demand relevant factors. Nope, because we've randomly selected these participants. And so, as we said, with a really large sample like this, yeah, we would check actually before we do the analysis that the means are the same for everything relevant. But actually, because we have so many consumers, we actually don't need to worry about this. This is like the goal of good experiment design. It's not to have to worry about controlling for those factors because we've done it with our experiment. Be suspicious because 20 is large relative to your surveyed prices. Yeah, as we discussed, we didn't ask anybody about $20. We asked about 10 and 15, right? So we can trust our results, but be a little suspicious, a little bit wary. So be as reasonable. And what should we do? Experiment further by offering the price of $20 to a subset of your demanders, potentially vary the price using discount coupons. Why coupons? Because you don't want to upset your demanders, if your consumers, if you change the price a bunch. And you don't want to print off 20 as being the price we're going with. And we don't want to have to you don't have to mess around with prices. So what I would do, and like we discussed in class, is let's take this $20 price, let's test it out and see if it actually works. Let's do further experimentation. And a reasonable way to do that is to have discount coupons if we need to, right? Okay, so horizontal characteristics refer to features of the product the consumers might have specific preferences over: taste, color, flavor. For some reason, you don't need to worry about price competition. Maybe it's fixed by some regulatory authority, just like the ice cream or beer on the beach example that we had. What do? Optimally locate as near as possible to any rivals. We call this the principle of minimal differentiation. You move to the center, right? So you can be as close as possible. You can minimize the transaction cost for customers. You don't want to locate as far away from rivals. This is increasing product differentiation without being able to benefit from it, right? So you could locate far away from your rivals. You could offer different product dimensions, which is fine, but you're not going to be able, you're just moving farther from your customers. You're not going to be able to benefit from carving out your own niche if you're not allowed to then raise your price, right? Remember, the point of product differentiation was to get away from fierce price competition. But if there isn't any, because the price has been fixed by the regulatory authority, then there's no benefit to incurring presumably the higher cost associated with differentiating products. Deploy as many versions of the product as possible. There's no reason to do that. What are you going to gain? You can't change your price. Use bundling or two-part tariff as an optimal pricing strategy? No, because your price is fixed. It's just whatever they say it's going to be. Okay, you got two products, blue and maize, to sell to two different customers, type A and type B. Each could potentially purchase both products, right? So this is a bundling question. We assume they're information goods, so it's natural the marginal costs are zero. And so the table reflects consumers' willingness to pay for the two products, right? So it's 10, 8, 5, and 6. Find the optimal pricing strategy when sold separately. Find the optimal pricing strategy when sold as a bundle. And then if we have willingness to pay of 80, would we want to use bundling? Okay, so if we're pricing separately, we could set the price of blue at 10 and sell only to type A. Fine, but then we're only going to get $10. If we just set the price at 8, we could get 16 because we'll get both type A and type B to buy. Similarly with maize, we could set the price at 6 and maximally extract surplus from type B consumers, but why would we do that? We could set the price at 5 and then sell to both and get revenues of 10. And so the best thing to do is to set the price at 5 and 8, and then profits are going to be 26 total. The best bundle, remember we could add up the prices, so 10 plus 5 is 15 would be how much type A pays for the bundle. Type B would pay 14 for the bundle, 8 plus 6. If we set the bundle price at 15, we get the most that A would pay, but we could sell another bundle. If we set the price at 14, we could sell to both type A and type B, our profits would be 28. What if this is 80? Replace the 8 with an 80. Now we've got a problem. Actually twofold. One is we then have positively correlated preferences, so immediately no, we don't want to use bundling. Or at least it's not beneficial, right? We have positively correlated preferences. Turns out, because 80 is so large relative to the rest of the matrix, we wouldn't want to use the bundle anyway. The bundle would be price, set the price at 86, right? There's two bundles. We could offer a bundle price of 15, but that'd be silly because then we'd have profits of 30, but if we set a bundle price of 86, we'd have, $56 more profit. So we wouldn't do that. Or we could set the price of blue equal to 80 and maximally extract surplus from type B, and then we could set the price of maize not at 6, but at 5, and then we could sell actually to both, right? So set the price at 80 for blue, only B buys. Set the price at maize at 5, both buy, and then we get $90 in profit, which is better than the bundle of 86 that we could only sell to type B. All right, so the two-part tariff question. There's 100 consumers represented with demand. Price is equal to 90 minus 1/3 Q. 100 represented with demand. P is equal to 90 minus 1/6 Q. Costs are 30 Q regardless of who you sell it to. This is total cost. C of Q is 30 Q, right? If we sell 1 unit, costs are 30. If we sell 2 units, costs are 60. 3 units, costs are 90. So our marginal cost is 30. But we also see that as just take the derivative, right? This will be 30. Want to use two-part tariff. Okay, so if we must sell using the same per unit price, for now it's price equal marginal cost and the same fixed price for both groups, find the optimal per unit price and compute profits. So here I told you the price has to be 30 because price is going to equal marginal cost. If the price is equal to marginal cost, then the optimal tariff is just going to be the consumer surplus that results. And so we want to check the consumer surplus that results for the small group. We could set the tariff equal to that amount and then sell it to both, so we get 2 times whatever that is. Or we could set the tariff equal to the consumer surplus for the large group and only sell it to them once. Suppose you must offer the same fixed price to both groups, but are free, and I'll go over the math in a second. Suppose you must offer the same fixed price to both groups, but are free to set any price, find the optimal per unit price, compute profits. This is where we want to set up profit as a function of price, take a derivative, right? The tariff portion is going to come from the smaller of the two demanders' consumer surplus. So we'll write that triangle as a function of price, drop that into our profit function. We'll have our per unit profits from both groups, take a derivative, find that price, drop that price into our expression for the tariff, and we're all set. Suppose you wanted to separate the two groups and offer each its own per unit profit or per unit price and fixed price. This is like third-degree price discrimination. Separating our two groups, we've isolated them as homogeneous groups of demanders. If you have homogeneous demanders, we want to set price equal to marginal cost and the tariff equal to their respective consumer surplus. Turns out you've actually found that incidental to completing part A, right? So we just need to put that together for part C. So C should have followed pretty closely after B. All right, so let's look at this work. So for part A, what could happen? Well, let's write out our demand. Here's demand for the small group. Here's demand for the big group, right? So our demand was for the small group, was price is equal to 90 minus 1/3 Q. So solving for Q, we'll need that for per unit profits, but drawing the graph, we can write 90 on the vertical and then 270 is going to be the horizontal intercept. For the other one, it's going to be 90 and then 540 is the horizontal intercept, right? And then here I solved so we can get our per unit profits. And also so we can get our quantity associated with that price of 30. Well, I needed to calculate consumer surplus at a price of 30. It's going to have the area of a triangle. It's going to be 1/2 base times height. The vertical is going to be 90 minus 30. That's this right here. And then the horizontal is going to be, what's my quantity demanded at a price of 30 minus 0? So the quantity demanded at the price of 30 is Q is going to be 270 minus 90, 3 times P. Right? So this is going to be 1/2 times 60 times 180 or 540. So we could set our tariff price at 540. We'll sell it to both. So our profits would be, from tariff anyway, would be 10,800. Under the large triangle, our tariff would be 1/2, the same vertical, 90 minus 30 is 60, so 1/2 60, and then it'll be 540 minus 180 is 360. Oh, it's 1080. You might remember this sort of structure from the examples we might have seen, that because one is kind of double the other, the same thing happens to their tariff. And so it turns out our profits are going to be the same either way, right? So either we set our tariff, either way we're setting the price at 30, and either we're going to sell to this, we're going to set the tariff equal to what the small group is getting as consumer surplus, 5,400, sorry, I missed 540 a bunch of times, that's this right here. 5,400 times 2 is going to be 1080, or just set it equal to 1080 from the get-go and only our high demanders are going to buy. And we'll lose all our low demanders. Here's part C. Part C is the best of both worlds. It's the ideal where we can treat this group separate from this group. They both see a price of 30, and then the small group gets a tariff of 540. The big group gets a tariff of 1080. Total profits are 16,200. So here is part A. Put that together, that gives us our answer to part C. Remember the symmetry between part A and part C? Okay, so what about part B though? Here's where we have to write out profits as a function of price. So I need to get an expression for my low group's consumer surplus at the price that we're going to be setting, or optimally finding and then setting. So it's going to be 90 minus P. Here we use 30 because we set price equal to marginal cost, but now we're just going to have some random price. We don't know what the price is, so it's going to, not random, but indeterminate, as of yet undiscovered price. How about that? 90 minus P is going to be the vertical, and then it's going to be our demand. It's going to be 270 minus 3P on the horizontal. And so that's going to give us actually 90 minus P, that whole quantity squared. Why? Because we can factor out a 3 here. Factor out a 3, this will be 3 times 90 minus P. Oh, we had a 90 minus P there, so we've got 2 of those things. That's this 3 here. That's why I wrote it this way. This 200 is because we had 100 of each type of consumers. The 1/2 was the 1/2 base times height, so it's going to be 200. 3 times. It's going to be 100 times 3. That's going to be 300. What's this 600 doing here? Well, when we take the derivative, this 2 comes out front, so it's going to be a 600. So we continue that derivative, right? This comes down. This is going to be 90 minus P, and then we take the derivative of the inside. It's going to be this minus 1. Right? And then just like simplifying this algebra, then maybe I divided, let me do the rest of it because I divided through by 100 to simplify it. This right here was my demand for the small group. Here is my marginal cost, price minus 30 times 100, because we have 100 of those people. And then 540 minus 6P, this was my demand, and then times the price minus 30 gives me my per unit profits from my high demand group. Actually, I got 100 of those, so I multiplied that by 100 too. Can you tell I forgot about the 100 initially? I had to write that back in. Yeah, that's why that's there. All right, so here's my per unit profit from the low group. Here's my per unit profit from the high group. When I take that derivative then, the 100 is coming along for a ride in all these terms. I'm going to do this with product rule. Product rule is going to be what? The derivative of the second times the first. So 270 minus 3P times 1, didn't bother to write it. And then the derivative of the first times the second. Derivative of this is going to be minus 3 times P minus 30. That's this minus 3 times P minus 30. As I said, the 100 came along for the ride. That was this right here. Same thing over here. Derivative of the second times the first is going to be 540 minus 6P. And then the derivative of the first is minus 6 times the second. Price minus 30, right? That's just product rule. Yeah, you could have foiled this thing, and then you have a whole bunch of terms, and I can't do that because I'll make a sign error, and because I like to do this in my head. And so, so I would just recommend doing it this way. But however, as long as what you did was mathematically correct, then it works out. All right, so once I had this thing, I didn't want to deal with those hundreds, so I just divided through by 100, because this is a 0 here, because we took a derivative. This was our first order condition, actually. Divided through by 100, and then it's just cleaning this up. Right, it's just a bunch of algebra cleaning that up. So I ultimately got a 540 divided by 12, or I got a price of 45. And if you plug that back into my expression for my tariff profits, so 90 minus 45 squared is 45 squared times 1.5, gave me my 675 divided by 2. Or 6,075 divided by 2 was my tariff. And then you can calculate out tariff profits. I guess I didn't write them out here, but just take your price, drop it into this profit function, and you calculate out tariff profits. It's somewhere between 1080 and 16,200, right? Because this is the part C gave us the optimal tariff. We could isolate those two groups and fully extract surplus. Part B gave us the optimal price when we're serving both groups. And then, why do we want to do that? Well, because probably C isn't on the table, right? So probably the profits we'd get from our optimal pricing in part B is the best we're going to do. This is, suppose you're able to separate the two groups, offer each its own per unit price and fixed price. Yeah, if you can do that, that's what you want to do. Often you wouldn't be able to, right? Anyway, so that was that one. In this question, we want to determine the advertising elasticity and the optimal level of advertising, assuming the following demand equation. Right? Suppose we have the estimated parameters of the equation with the following results. Ad copy is a dummy variable. Ad copy is equal to 1 for emotional advertising. Here's our estimated coefficients and the respective T statistics. Compute the advertising elasticity, assuming ad dollars is 8. A competitor ads is 19 using emotional ad copy. If the price elasticity of demand eta is -2, what percentage of sales ought the company be advertising? Remember, I said in class, right? We did this in class. We had 3 different levels of ad dollars. We had 250, 475, and 8. And I said, hey, it would be interesting to redo this at 250 or 8, right? Because we did it for 475. Look and see how it would change. So if you did that, if you did this on your own, then you already solved the problem before you came to the exam. If not, then it's easy enough to do because I gave you the equation. So what do? We just evaluate by dropping in our estimated coefficients. So here's our 3259 for our beta naught. Our beta 1 was 1.48. Our beta 2 was -0.57. Our beta 3 was 2.13. Ad copy emotional 1. Okay, competitor ads, I told you that was 19. And then our level of ad dollars was 8. Add this up, and this gives us our quantity demanded, right, at the price of 8 with this competitor ad level and this ad copy. Then we can calculate our advertising elasticity of demand. Remember, the formula looks just like price elasticity of demand. It's the slope times the point, right? So dq dA times A over Q, right? So dq dA, well, that was the slope, the partial slope that we estimated, right? Our partial slope we estimated was the 1.48. That was the coefficient on ad dollars. And then our point, well, we had the ad level, that was 8, that's kind of given. And then right here, and then we have the quantity, 35.73. So if you calculate this, you get 0.33. Remember, our formula was advertising elasticity divided by price elasticity of demand equals the fraction of sales that is our advertising. Okay, so 0.33 divided by -2, right, tells us 16% of our sales, right? Okay. And sorry, this should have been an absolute value. So this should have been, it's not, I know, you can't have -16%. I should have done this in absolute value, and I don't know. I didn't do that. So sorry. All right, so then the last one. Consider following prices for a meditation app. $15 per month for a basic version with pre-recorded sessions. Marginal costs are $10. $60 per month for a premium version with live sessions and access to a full library of pre-recorded sessions. Marginal costs are $20. I'd find it super distracting if you're watching, if you have like an interactive live session. So I'm assuming that this is like some type of broadcast, right? That's happening live. Anyway, so for our purposes, assume all fixed costs are already been paid, therefore sunk relative to what we're asking. Following table gives us willingness to pay the 2 types of consumers. Presumably, you're not going to buy both the basic and the premium subscription, right? You buy one or the other. Either the basic is good enough for you or the premium is. So this is a second-degree price discrimination problem, right? We're going to set a price for basic, we're going to set a price for premium, and either consumer could buy either one of these. All right, so are they pricing optimally if they're setting the price of $60 per month? Well, if we're pricing optimally, what we want to do is we want to set the price of type A equal to $15 and the price of the basic subscription equal to $15 so that the type A consumers are exactly indifferent between buying and not buying. Then what we want to do is we want to set the price of the premium equal to $57, and then our type B consumers will buy the premium. The current premium price at $60 is too high, because the consumer surplus to the type B consumers would be 0. They were willing to pay $60, the price is $60, but why would they do that? Because they also see the price for basic at $15, and they would have consumer surplus of 3, because they would have paid $18 for that one. But you're only asking everybody to pay $15 for it, right? So we have to make sure that when buying the premium subscription, our type Bs get at least $3 of surplus. So the price has to be no larger than $57. So a good answer would have been $57. Another good answer would have been $56.99 as how they should adjust it, right? you wouldn't probably want to set it at 55 because that's cutting the prices lower than you'd need to get your type B consumers to buy the premium package. Bombas is an e-commerce site selling designer socks and other apparel. When you purchase from Bombas, they will donate another pair on your behalf. Conduct a Porter's 5 Forces for Bombas prior to entry. We covered this example in class, and so should be familiar with Bombas. And we did this exam. We did Porter's 5 Forces in class. So you should be familiar with this. So therefore, I just gave us I filled at this table. You probably could have made the table yourself, but I just did this real quick, just the same one we used in class. So you just need to put a check for low, medium, or high, and then explain why you designated each as it did. And I was pretty flexible with this. So what I said, though, for rivalry, pretty high. There's a lot of companies selling fancy socks. And I understand, yeah, they've got like a different twist on this because they do have this pro-social, kind of charity aspect. But as regards just socks, right, there's a lot of firms doing this, selling socks, I mean. Entry, pretty high threat because it's pretty easy to enter the sock market, all things considered. I would imagine anybody selling any type of apparel could also probably sell socks, right? So anybody could probably do this that's already in the industry. And then you can find, if you wanted to sell socks, you could find a manufacturer that would manufacture your thing as long as you were placing a large enough order. Would be, anyway. So buyers. Well, the force for market power of buyers is low. Each individual is buying like a couple of socks. Even if you bought enough socks to last you for the year, that's small relative to the total output that Bombas is making. So market power of buyers is low. Market power of sellers, I'd say low to medium. So there's a lot of textile mills that can make socks. Maybe in terms of like ones that are going to be willing to make your specific designs and have like the texture and everything you want. Maybe there's fewer, but there's still like lots of options to make socks and to produce textiles.